Hello friends, welcome back to our channel. In this video, we are going to discuss one very important interview question, that is the design of a parameterized pipeline. Although I have discussed the same question in one of my previous video as well, and I will give the link of that video in the description section as well as in the I-bar section. In that video, I give the solution to design parameterized pipeline with the help of Verilog Code, and I use generate and for loop. And one of my channel member commented me that, sir, please make it simple and design it with the help of shift register. So in this video, I'm going to design the same parameters pipeline with the help of a shift register, and that method is very simple. So that is why I thought of repeating the video. Now without wasting much time, let us get started. Friends, let us start our video with a very simple problem statement. In this question, you have A input, clock input, Y is output, and we have to put 3 flip-flops in the middle. Now let me tell you the Verilog code. It is very simple. We already discussed it in my previous video. We have to take 3 registers, A underscore FF1, A underscore FF2, A underscore FF3. Always at the rate passage of the clock begin A underscore FF1 equal to non-blocking statement A. Similarly, A underscore FF2 equal to non-blocking statement A underscore FF1. A underscore FF3 equal to non-blocking statement A underscore FF2. So this is going to yield 3 flip-flops as required in this question. Now let us move towards the crux of the video, where we have to design a parameterized pipeline. When I say parameterized pipeline, that means between A and Y, I may require n number of flip-flops depending upon, let us say, one of the parameters which I am taking as an input to my module. Friends, those who want to know the method which I discussed in my previous video, that is with the help of generate and for loop, they can visit my previous video. Otherwise, here I am going to mention you the very simple method with the help of a shift register. Friends, on your screen I am presenting the Verilog code, which is very simple, and I am taking the help of a shift register in this design. So this is the module name FFN. FFN stands for n number of flip-flops. So here I am taking parameter n. For this example, I am taking n as a 7, but you can change it to any other numeric value, 3, 4, 10, anything. And this module has 2 inputs, A and clock, 1 output Y. Now to design a parameterized pipeline with the help of shift register, so we have to consider register A underscore FF. Its width will be equal to n minus 1 down to 0. So in this case, n is 7, so 6 down to 0 will be the shift register, that is 7 bits. That is our required pipeline. Now how we design it? Always at the rate passage of the clock. So A underscore FF non-blocking statement equal to A, which is our input. So input I am giving at the MSB, and then A underscore FF n minus 1 down to 1 I am appending here. So that is nothing but simple shift registers. And Y will be equal to A underscore FF 0th index. And that is all. So this is how we can design a parameterized pipeline, and we can avoid generate and for loops. So it is very simple code. Friends, in case we are going to synthesize the same design for FPGA implementation, in my case I have used Vivado to synthesize my code. And one very important finding I want to share with you is Vivado is able to identify that I'm going to use a shift register. And instead of using all the distributed flip-flops, it is trying to use inbuilt shift register. So what is the advantage of using inbuilt shift register? Because these shift registers are very fast. So in case I'm using all the distributed flip-flops, this implementation will be quite faster. It will be able to operate at higher clock frequencies, and our area will be efficiently utilized. Friends, in our previous video when I used generate and for loop, the Vivado was not able to figure out that it is a shift register. So it was using distributed flip-flops. But in this case, when I am using shift register approach, Vivado is able to identify that I am using a generic shift register, and it is trying to use inbuilt shift registers. So which is making our implementation quite efficient in terms of frequency and in terms of area as well. Friends, with this I am going to end this video, and I hope that this would be quite informative for all of you. And in future we are going to create many such videos. So to be aligned with our channel, don't forget to subscribe it, and to get the notification of all the upcoming videos, press the bell icon. Thank you so much for watching.